So today we're going to start a new portion of our chapter inverse trigonometric function, that is 1 and onto function. Okay, we need to know this one in order to proceed with the inverse of a function. Now first thing, what is a function? A function is a special kind of relation in which every element of A has one and only one image in set B. Okay, so you see in the right hand side corner there is an arrow diagram in there. So I see there is set A, and in set A the elements are 1 and 2, and in set B there are elements that is A and B, right? Now I am relating the element 1 with element A of set B, element 2 of set A to element B of set B, right? So this is a relation. I am finding relation between two elements, right? Now what I see in here, that every element of A has one and only one image. So I can say that particular relation is a function. Understood? Clear? So a function is a relation in which every element of A has one and only one image in set B. Now function is denoted by f colon A to B. Now suppose if I have an element 3 in there, now will it remain a function? No. Why not? Because all the elements of set A needs to have one and only one image to be a function, but in here 3 does not have an image, right? So this is no more a function, so it just remains a relation. Okay, clear? Now if I relate 3 with B, now can you tell me, is it a function or not? Now in this one it is a function, okay, because every single element has one and only one image. 1, 2, 3, all of them has one image. It doesn't matter whether 2 or 3 elements have the same image or not. My main concern is that every element needs to have one and only one image. Now let's proceed to 1 function. So what is 1 function? A function in which distinct elements in set A have distinct images in set B. What do you mean by that? It means different elements in set A needs to have different elements in set B. Look at here, 1 has element A, 2 has element B, but 3 has element B again. So this is not a 1 function. Am I clear? Understood? Every element in set A must have distinct images in set B. Okay, now below here I have done two functions. I am showing you two functions in here. You see one, you see the first function, the left hand side, you see that element 1 is linked with element 2. Element 2 has an image, element 3. Acha, image is what? Suppose I say element 1 of set A is related to element 2 of set B, then element 2 is the image of element 1. Am I clear? So you see, element 1 has one image, element 2 has a different image, element 3 has a different image, element 4 has a different image. So if different elements of set A has different images in set B, then we can say that function to be 1 function. Am I clear? Okay, understood? You see, now you can see the clear picture of it. So 1, 2, 3, 4, 5, and here their different images are 2, 3, 4, 5, 6. Okay, understood? So that's our 1 function. Now this is a function, I am writing f colon A to B, it's going from A to B. Now the function I defined, fx is equal to x plus 1. So if I put x as 1, and fx can be written as y also. So y will be equal to 1, so y will be equal to x plus 1. So if I say x as 1, so y is equal to how much? Y is equal to 1 plus 1. Yes or no? If I put x as 2, then y will be equal to what? 2 plus 1. Am I clear? Understood? So what can I say about function? So f of 1 is equal to, f of 1 will be equal to, just look at the x plus 1, f of 1 will be 1 plus 1. In place of x I will just put 1. Understood? And that is 2. So like this way we relate each and every element of set A to set B. Okay, and this relation is called functions, right? For the moment, don't look at what is written below that, that is x is equal to y minus 1. Don't look at that thing. So this one is 1 function. Okay, Now what is the definition of onto function? A function in which every element of set B is the image of some element of set A. So it says what? Every element of set B is an image of some element of set A. So look at the first function. You see 2 is an image of 1, 3 is an image of 2, 4 is an image of 3. So every element of set B is image of some element of set A, right? So the first function is our onto function also. Clear? It's 1 1 and onto both. Understood? Okay. Now let's look at the second function. Can you tell me, is it 1 1 or not? The second function is not 1 1. Why? Because -2 and 2 have the same image. Understood? -1 and 1 have the same image. Here the function is fx equal to x square. -2 whole square is 4. I hope everybody knows this thing. So y is equal to x square. Clear? And this x is equal to root y we will discuss later. Now can you tell me whether this one is onto or not? This is not onto because all the elements are not image of some elements of A. Why? Because -1, 2, 3, they are not images of set A. Am I clear? So the second function is neither 1 1, neither onto. Understood? I hope I am very clear about this one. So what is 1 1 and what is onto function? So please write this down clearly. So function in which distinct elements in set A have distinct images in set B, that is 1 1 function, and a function in which every element of set A is the image of some element of set A is onto function. Am I clear? Okay, and function is denoted by fx. So now if I put an element 7 in there, can you tell me now will it be onto? Will it be onto? No, it won't be onto because there is one element in set B which has no image in set A, right? So it is not onto. Understood? Am I clear? Okay. Please copy it down as fast as possible. So today we get to know about 1 1 and onto functions. Now I will be telling you why we are studying 1 1 and onto. Okay. For the moment, just realize what is 1 1 and what is onto. Can you tell me what is domain? What is domain? We have discussed domain. All the elements of set A which are related with the elements of set B, right? Yes or no? All the elements of set A which are related with the elements of set B. Look at the second function in here. What are the elements that are related with set B? -2, -1, 0, 1, 2. So the domain is -2, -1, 0, 1, 2. Okay, that's what the domain is. And what is range? Range is all the elements of set B which are related to the elements of set A. Now in the second function, can you tell me what is the range? The range will be 0, 1, 4. Okay, so those are the elements which are related with the elements of set A. Am I clear? Okay. So domain is all the elements in set A which are related with set B, and range is all the elements of set B which are related with set A. Okay, clear? And there is another thing, that is codomain. Codomain is basically all the elements of set B. So in second function, if somebody asks you what is codomain, you will write all the elements of set B. So it means what? -1, 0, 1, 2, 3, 4. It doesn't matter which are related with elements of set A or which are not. We'll just write all the elements. Okay, clear? Now let's study about the inverse of a function. So first thing what we need, for inverse a function must be 1 1 and onto in order to have an inverse. So a function needs to be 1 1 and onto, then only we can find the inverse. That's the reason we discuss about 1 1 and onto function. Am I clear? So the necessary condition for a function to have an inverse is that it needs to be 1 1 and onto. Understood? Now we will be discussing about inverse of a function. Okay, so what we see in here, look at here, these are the inverse, these are the starting point of the inverse of the first function and the second function. Look at the first function, the domain is what, 1 2 3 4, and the range is what, 2 3 4 5 6, right? Now I am trying to find the inverse of the first function. So what will be my first step to find the inverse of the first function? So my first step to find the inverse of any function is that the domain and range will interchange. Here I am writing set A, here I am writing set B. Set A and set B will interchange. You see the domain and range interchanges. Okay, when I am finding inverse, the first step is I have to interchange the domain and range. Now here we had this function as y is equal to x plus 1, right? Now y was expressed in terms of x. Now we will be expressing x in terms of y. Since we are finding inverse, x and y will interchange their position. So here it's not interchange from the equation y is equal to x plus 1, so it will become x is equal to 1 will go that side, so it will become x is equal to y minus 1. Understood? Am I clear? Okay, so now my function changed. I have got a new function, that is x is equal to y minus 1. Previously we had what, fx is equal to x plus 1, right? Now we have a function which is defined in terms of y, right? Am I clear? Yes or no? Please. So previously we were relating x to y, right? Now what we will be doing, we will be doing from y to x. X is equal to y minus 1. So if I define the function, new function, that is y minus 1, as fy is equal to x, fy is equal to x, just like fx is equal to y, we will just switch their positions. So fy is equal to x. Actually, you know what, the function will never remain the same. So let us give it a name as g. Gy is equal to x. Okay, and where gy will be equal to what, y minus 1. Fx was equal to what, x plus 1, and gy will be equal to y minus 1. Okay, clear? Everyone understood about the inverse? So x and y, they will interchange their role play. Understood? So in here what we see is, we will define the function just like the previous one. The first function we defined that one as fx is equal to y, right? So this one will define as gy is equal to x, where x is equal to what, x is equal to y minus 1. Okay, clear? Where x is equal to y minus 1. Understood? So this is our new function. That is basically the inverse of the previous function which we are doing. This is the new function. And one thing, the previous function we started with, that is 1 1 and onto. Am I clear? That was 1 1 and onto. So now let us see. Now tell me, when y is 2, x is how much? It's 1. So y 2 and 1 is related. And when y is 3, x is 2. So like this way we will have relations like this. Understood? Between two elements of set A and set B. So this is a g function, and this function, the inverse function, is denoted by f inverse, like that. That's how we denote inverse function. Okay, now you see we have easily found the inverse of this function, right? Understood? So if somebody asks you what is g2 equal to, here it was what was f1 equal to, you got 2, right? So here what will be g2 equal to, g2 will be equal to 1, g3 will be equal to 2, g4 will be equal to 3, like this it will go. Okay, or else you can write f inverse 2 is equal to 1, f inverse 3 is equal to 2, f inverse 4 is equal to 3. Okay, understood? Clear? So this is how we define an inverse function. Okay, now let's move on to the second function. the second function, sorry for the disturbance, the second function what we have is the domain is -2, -1, 0, 1, 2, right, and the range is what, -1, 0, 1, 2, 3, 4. So when we try to find the inverse, what we will do, we'll interchange the domain and range. That's what we discuss. Yes or no? Here the function was what, fx is equal to x square, right? Okay, I'm sorry, y is equal to, it will be x square. So it will be y is equal to yeah, we had to write that thing. Wait a second, I'm gonna write. So look at here, the domain and range interchanges, right? So here for that previous function, now why we're discussing this? Now we are trying to prove that a function which is not 1 1, which is not onto, it does not have an inverse. Okay, now we are going to prove that thing. Am I clear? Previously we had a function that is 1 1 and we had a and onto, and we found the inverse of it. But now we'll be dealing with a function which is neither 1 1, which is neither onto, that it does not have an inverse. Now, so y is equal to x square. Just like previously, y is expressed as x, so x will be expressed as y. So I can write x is equal to root y, right? Now look at these two things carefully. X is equal to root y. Okay, so everyone clear? In order to find the inverse of any function, first thing what I will do is I will interchange their domain and range, right? Then we'll start with the mapping. Okay, so here the function is again gy is equal to x, right, where x is expressed as x is equal to root y. Everyone, I hope everyone is clear about this one. So we are defining a new function, that is gy is equal to x, where x is equal to root y. Am I clear? Now look at the graph, look at the arrow diagram which we are going to do carefully. So can anybody tell me, okay, first thing, look at both of them clearly. So -2, -1, 0, 1, 2 was the domain, 0, 1, 4 was the range, right? Understood? Now here it was what, fx equal to y, right? And we define the inverse of it as gy is equal to x. Clear? So we're going to start with the mapping. So first thing first, copy it first. Do it first. Copy this one. Because these are important. In order to understand the concept of inverse, you need to know 1 1 and onto. Am I clear? Look, we can skip this portion and we can go directly to formulas and all. But in order to get a grasp of a chapter, we need to know the basic roots of the chapter. What are the roots? What is inside the ground of the chapter? Okay, if our base is not clear, our whole tree will be shaky and someday it will fall down. Okay, understood? If the root is strong, then the tree will keep on standing. Yes, so now let's relate. Now when y is -1, can anybody tell me what is the value of x? So x is equal to root over of -1. What is that? So what will be the image of this one? Root over of -1, where we have seen root over of -1, it is basically iota, and it is what? Imaginary number, right? But in here in functions, we are dealing with real numbers. So when we are dealing with real numbers, we have to think of something that root over -1 is imaginary, that it is kind of like undefined. Okay, so what can I say is that when I have y is equal to -1, that root over of -1, the image does not exist. Am I clear? So the image of -1 does not exist. Okay, clear? So we cannot perform the mapping of -1 to any of the elements of set B. Now you see, when y is equal to 0, so what is the value of x? So when y is equal to 0, so we get what? Root over of 0, right? So when y is 0, we get x also 0, right? So we perform the mapping from 0 to 0. 0 of set B will be mapped with 0 of set A. Am I clear? Now tell me, when y is 2, what should I do? So when y is 2, we get what? Root 2, right? So root 2, again root 2 does not have any image. You see, whatever elements we have taken, we are just doing the mapping with those elements. So 2 does not have any image. Same goes with 3 also, we get root 3. Root 3 also does not have an image. Yes or no? Clear? But 4, square root of 4 is what? Plus minus 2. So 4 has two images. One is minus 2 and plus 2. Right? So now tell me one thing. When I say inverse function, so inverse function is what? It is also a function. So it also have to follow the condition of a function. That is, every element of A has one and only one image in set B. Now can you see that every element of set A has one image in set B? No. Minus 1 has no image, 2 has no image, 3 has no image, and 4 has two images. Clear? So the condition for function is not satisfied. So this one, the second function, is not a function. So you see, that's the reason a function needs to be 1, 1 and onto in order to have an inverse. Am I clear? Look, the second function was a function, but the inverse of it is not a function anymore. So inverse does not exist. So what are the conditions I have written in here? It exists only when the function is 1, 1 and onto. Okay, that's the thing. Now let's move on to the second point. It's the most important point. That's how what defines the concept of inverse of a function. If x colon x to y such that fx is equal to y is 1, 1 and onto. So we have told that the function is 1, 1 and onto. Then we can define a unique function. So every function has a unique inverse, right? Then we can define a unique function g colon y to x. You see the domain and range interchanges such that gy is equal to x, where x is an element of the set x and y is equal to fx, y is an element of set y. Now let's see in here. So here it was what? F colon a to b, right? The function was what? From a to b. Understood? And here fx was equal to x plus 1. Fx equal to y or fx equal to x plus 1. 1, 2, 3, 4, 5. Where are the elements? They are x actually. They are elements of a, right? 2, 3, 4, 5, 6. They are elements of what? Set b. Understood? So if we do the inverse of it, so what happens? Now the inverse of it, I define that to be g function. So our range and column, our range and domain interchanges, right? So this becomes b and this becomes a. So just like this one, what we have done in here, f colon a to b. Can you define the inverse? So what will be the inverse of this thing? The inverse of this thing will be, think clearly and tell me what will be the inverse of it. Think. If you don't think, if I'm gonna say everything, then you will not get it. First thing, you have to think, you have to apply your mind, you have to use your mind. Then only you can do good in mathematics. You cannot just copy everything up and just memorize. Mathematics is a conceptual subject, right? So in here it was what? F colon a to b. So here it will be g colon b to a. Here the elements are related from, it starts from b and it's end at a, right? So the arrow, so that if I do the arrow diagram, it's originate from b and it's end at a. Am I clear? Understood? So this is how we define an inverse of a function. Okay. Now we already discussed that domain of the inverse function becomes the range of the given function. The range of the inverse function becomes the domain of the given function. Okay, everyone, have you understood the second point? I think there is a certain kind of a doubt in the second point in there. Acha, fine. Then we'll explain it further. Wait a second. First, everyone note this thing down. Note it down. So look at this one carefully. F colon a to b, right? Wait a second. So now let's discuss this one more simply. So what we have in here, let us consider two small form of arrow diagram. So we have general form. So we have the first set as the elements as X, and that is capital X is the set, and here we have the elements as Y. The set name is capital Y, right? So the X elements are related to the elements Y, right? So the arrow will originate from X and terminate at Y. So the function will be defined as f colon x to y. Clear? Now if I have to find the inverse of this function, this will be what? Think, if I have to find the inverse of this function, it will be from y. Y element will come there and x elements will go there, right? So here it will be the arrows will originate from y and it will terminate at x. You see x and y interchange their position, and here we have g colon y to x. Understood? And that is what is mentioned in the second point. Am I clear? Understood? Okay. I hope everyone is clear about this one. Look at it carefully. From the above diagram, f colon a to b, the function is fx equal to y, and if we do the inverse, we get g colon b to a, and the function is gy is equal to x. Okay, where x is an element of capital X and small y is an element of capital Y. Clear, everyone? Okay. Understood? Now, so you see 1, 2, 3, 4 are basically X, and 2, 3, 4, 5, 6 they are basically Y. Okay, clear? So that's why they say X is an element of A and Y is an element of B. From this example we have this, but from there for the general one we say small x is an element of capital X and small y is an element of capital Y. Okay, clear? So look at these clearly. And here we have already told that inverse of a function. Please remember this one, clarify this one, that a function needs to be 1, 1 and on 2 to have an inverse. If it's not 1, 1 and on 2, inverse not possible at all. Am I clear? Please have this concept very, very clear, because this is the main idea we will be using. Okay, understood? So let's move on. So I already discussed that the domain of G becomes the range of F, they interchange, and the range of G becomes the domain of F. You see, 1, 2, 3, 4, 5, it is what? Domain of F. It becomes what? Range of G. 1, 2, 3, 4, 5. And you see the domain of G is what? 2, 3, 4, 5, 6, right? And 2, 3, 4, 5, 6 is basically what? The range of F. Am I clear? The domain and range interchange themselves. Understood? Okay. And here it's not possible at all. And here you will see for the second function, there is the domain and range does not matches. Interchanging though, it's a second story, but first place it does not matches at all. Clear? The first thing is that it doesn't matches. Now the inverse of the function G is called the inverse of F and it's denoted by F inverse. So if these conditions are followed, the G is called the inverse of F and it's denoted by